All right, this is 7th grade, Module 4, Lesson 11. This lesson's about tax, commission, fees, and other types of percent problems. So we're going to start here with this first one. It says, how are each of the following percent applications different, and how are they the same? Solve each problem, and then compare your solution process for each problem. Silvio earns 10% for each car sale he makes while working at a used car dealership. If he sells a used car for $2,000, what's his commission? So the first thing we're going to do is write down his total cost of the car, $2,000. And since his commission is 10%, I'm going to change 10% into a decimal and make it decimal 10. And then you just multiply that straight out. He's going to make $200. So we're going to say $200 in commission. And that's it. All right, let's look at B. Two's family stayed at a hotel for 10 nights on their vacation. The hotel charged a 10% room tax each night. How much did they pay in room taxes if their room cost was $200 a night? All right, so we're going to take $200 a night, and I first want to find out how much total that was for 10 nights. So times 10, that's going to give me $2,000. All right, so they spent $2,000, and the hotel charged them 10% each night. So we're going to say that $2,000 times the decimal 10 for the 10% is going to leave him with $200 in paid taxes. All right, let me scroll this up real quick here. All right, C. Eric bought a new computer and printer online. He had to pay 10% in shipping fees. The total came to $2,000. So how much did he pay for shipping? So again, the total of the items came to $2,000. Then he had to pay an additional 10% for shipping. So he paid an extra $200 in shipping fees. It's an awful lot for shipping. All right, let's look at D. Selena had her wedding rehearsal at a restaurant. The restaurant's policy is that the gratuity is included in the bill for large parties. And her father said the food and service were exceptional. So he wanted to pay a little extra. So he wanted to pay an extra 10%. So even though what he paid for the bill, which totaled $2,000, that included a tip, he wanted to leave a little bit even more. So he added an extra 10% to that. So the bill came to $2,000. Times that by the extra 10% tip he wants to leave. So he already tipped, and he decided to tip a little bit more, an extra $200 in tips. All right, let's go ahead and go to the exercises. All right. The school board has approved the addition of a new sports team at your school. The district ordered 30 team uniforms and received a bill for $2,992.50. The total included a 5% discount. So, first scenario here. The school needs to place an order for 2 more uniforms. They were 2 uniforms short. The company said they will not apply the discount for just 2. It has to be for orders $1,000 or more. So how much will just the 2 uniforms cost? All right, well, first off, they would have to pay the 100% of those uniforms. So 100% is all the uniforms with no discount, so 100%. Then, because they get the 5% discount, the school district is only paying 95% for those uniforms because that includes that 5% off. So we're going to take the total of $2,992.50 and we're going to set that equal to the 95% they were responsible for, turning that into a decimal, times how many uniforms they need to purchase. So X represents the number of uniforms. So this is basically saying 0.95 times what gives me $2,992.50. So we're going to divide that. I'm going to divide that by sticking it right underneath there. And now in your calculators, go ahead and put in 2,992.50 and divide that by 0.95. And your calculator should give you the answer of 3,150. So this is the cost before discount. All right. Now we're going to take that money and we're going to divide it by the 30 uniforms they did purchase, because up here they bought 30 uniforms and that's how they were able to get that deal. So what I'm trying to find here is how much is one uniform. So when you divide this out in your calculator, you're going to get $105. That's each uniform. All right, and since I need two of those, I'm going to say 105 times 2. So we need to pay $210 for the 2 uniforms. All right, now B says the school district does not have to pay an 8% sales tax on the $2,992.50 purchased. Estimate the amount of sales tax the district saved on that purchase. All right, so sometimes when you buy huge amounts of things like that, people will discount you the sales tax and say you don't have to pay the sales tax. It's kind of like the same thing as offering free shipping. So we're going to say $2,992.50 is close to $3,000. We're just going to round that up to a nice whole number. Now, since they got 8% off, we're going to change that to a decimal. So remember 8%, move 2 decimal places to the left. So it's 0.08. So we're going to say 3,000 times 0.08, and that's going to give me $240. So that's how much they saved in sales tax. All right. Now I go ahead and scroll this down. A student who loses a uniform must pay a fee of 75% of the actual cost of the uniform. For a uniform that costs $105, will the student owe more or less than $75? All right, so each uniform, as we found out above, and they told us again here, was $105. They have to pay 75% of that. So we're going to multiply that by 0.75. And when you multiply that out, you get the total of $78.75. So for a lost uniform, a student must pay $78.75. Is that more or less than $75? We're going to say it's more. So we're going to say a student will pay more than $75. Now, D says, write an equation for all this stuff that we've been doing, these past 3 problems. What would be our equation? Now, they want us to use the variable U for uniform and S for student. So the student, well, in this situation here with the 75, I guess, because it did say for the lost uniform right there. Okay, so not all the problems, just this last one. So the student would pay $0.75 of the uniform. And so there is my equation. Now it also wants to know what's the constant rate of proportionality. We're going to say the constant. In this case, what do I keep multiplying by? I keep multiplying by 0.75. So the constant is 0.75. All right, let's go ahead and go to the back. All right, a taxpayer claims that The new sports team caused his school taxes to increase by 2%. So write an equation to show the relationship between the school's taxes before and after the 2%. We're going to use B represent the dollar amount for the school tax before, and use T to represent the dollar amount of school tax at the increase. All right, so we know that they were paying 100% of their taxes before. And if we increase it by an additional 2%, it comes up to 102%. And that would include the increase. So our equation then is going to be T, the increase price, is going to be 102 or 100.2. And that's going to be the decimal version of 102% times B. All right, so you take your new percentage. We're going to keep multiplying that by whatever the tax was before, and that'll now give us our increased tax. Now it says, use your equation to complete the table below, listing at least 5 pairs of values. All right, so they already gave us some here, so we're going to use this equation to solve this out. Now I'm going to fill in the easiest one here. If I plug in 0 for B, anything times 0 is 0, so that just made that a little easier. Now this one, they want me to put 1,000 in for the B. So we're going to say 1.02 times 1,000, and that's going to give me the answer of 1,020. I'm going to do the same thing here with this one, 1.02 times 2,000, and that's going to give me the answer of 2,040. All right, now we're going to go the other way. All right, so I'm going to now have the T, and I need to find the B. So I'm going to say 3060 equals 1.02 B. So I'm going to divide 1.02 here, and 3060 divided by 1.02 comes to 3,000. And I got this last one here. I'll do it over here. It's going to be $6,120 equals 1.02 B. Okay, swing that guy right underneath there. And on your calculator, 6,120 divided by 1.02 gives you 6,000. All right, so we filled in our table. Now, I'm not going to graph this out for you guys, but you do need a piece of graph paper. Since these are all positive, you can just use a positive coordinate, which would be an L-shaped graph. This is going to be your B values. This will be your T values. Okay, and of course, you have a 0, 0. So go ahead and graph that out on a separate sheet of graph paper. Make sure to attach it to this worksheet. I'm going to scroll this up so I can do the next couple ones here. Now, after you you graph it and you connect your dots, make a line, you can answer this question here. Was it a proportional relationship, and how do you know? So I'll let you go ahead and answer this one. What was the constant rate of proportionality? So what was I constantly going up by? I kept going up by 1.02. So we're going to say the constant is 1.02. And it asks, what does that mean? What does it mean for this situation? So we're going to say it means after the 2% increase, $1.02 will be paid for every dollar spent on something. It gets an extra $1.02 added to that. All right, let's look at F. F says if a taxpayer's school taxes rose to $4,000 to $4,020, was that a 2% increase? All right, well, let's try this. If I took this and times it by our tax increase here, 4,000 times the 1.02, and I did that on the calculator, I get 4,080. So no, that is not a 2% increase. It must be a lesser value. All right, let's try the next one. We're going to go on to number 3. All right, number 3 says, the Sports Booster Club sold candles as a fundraiser to support the new team. The club earns a commission on its candle sales. If the club gets to keep 30% of the money from the candle sales, what would the club's total sales have to be in order to make at least $500? So we're going to actually set this one up as a proportional relationship. It'd be the easiest way. So we're going to say line equals line, all over 100. Now, this is how much money they would like to raise, but that's not the total. So that's going to be our part. And they do get to keep 30% of the sales, so there's our percentage. So what we're solving for is how much money do they have to total in order to get that 500. So we're going to cross multiply here, and I get 30x equals 500, and then add 2 more zeros on there, so 50,000. 30 times what gives me 50,000? So we're going to swoop this down below and divide those out. And when I divide it out, you're going to notice on your calculator, you get 1666.66, and that keeps repeating. So we can't have a repeat, especially when it comes to money. So we do have to kind of go ahead and terminate this. So our final answer will be $1,666.67. So that's how much they have to sell in order to make their $500 profit. I'm going to go ahead and move this up for number 4. Oh, a little bit too much. There we go. Number 4 says, Christian's mom works at a concession stand during sporting events. She told him they buy candy bars for 75 cents each and mark them up 40% to sell at the concession stand. So how much was the markup? And how much does the concession stand charge for each candy bar? Okay, so we know that the sporting event people, they buy the candy bars at 100% value, and then they take it and mark it up an additional 40%. So we're going to add 40% to that, and we get 140%. Now, to transfer that into a decimal, we get 1.40. So we're going to take that 75-cent candy bar, and we're going to multiply it by 1.40. That's 100% of what they paid for it and the 40% increase. So if you multiply those together, you get $1.05. Now that's the sell price. So if you and I walked up to the concession stand and we bought a candy bar, we'd pay $1.05. Now, how much is that markup? So we're going to say $1.05 times, nope, excuse me, not times, subtract. Try that again. Subtract that 75 cents. So this is what they sell for. This is what they bought it for. So how much money are they actually making on the markup and or profit? They're making 30 cents off each candy bar. All right. Let's try the next page. Now, I said this was with your group, but we're going to do this whole class in the classroom, and we're not going to make posters and such. We're just going to kind of talk this out and write it all out together. For the next school year, the new soccer team will need to come up with $600. All right, so here's our first scenario. Suppose the team earns $500 from the fundraiser at the start of the current school year, and the money is placed in a 1 calendar year in savings account, which earns 0.5% in interest. How much money will the team need to raise to meet the next year's expenses? So the first thing we have here is we have a 0.5%, so 0.5%. Now in order to change that to a decimal, I need to move it 2 places to the left, which gives me 0.005. So we're going to take that $500 that they need to earn, or that they did earn, they did earn that, and they put it into an account that's getting 0.5% of interest. So we're going to multiply that by 0.005, which will give you 2.5 on your calculator, which is basically $2.50 in interest. That's how much money they will make in interest. Not too much there. So how much would be their total balance in the bank? That would be $500 plus the $2.50 brings them to $502.50. Put some dollar signs around here. There we go. Now they need $600. So how much money do they still need to raise? So we're going to say $600 minus $502.50. So they need to raise $97.50 still. All right. Now this last one, B, I'm going to have you guys do on your own. So in that sense, this will conclude our tutorial because I'm going to have you skip C. This one is C, and C is not our standard for this grade level. So on this problem here, you can write skip. So go ahead and do B and then turn it in. And that's the end of this tutorial.